Lesson 12.5, the last lesson of Chapter 12. Woohoo! This is on recursive formulas. You guys actually have been exposed to recursive formulas a little bit. When you did your MCA review packet, you saw it there, and then we tried to just have you do a couple problems here and there throughout the chapter so that when you got to this it would be no big deal. So again, recursive formula, terms generated using the previous term in the sequence. This is where you need to be given the first term and you build off of the first term to get the next term. These are those rules where you saw this symbol A with a subscript of n minus 1. And if you think about that as a symbol for the previous term, so that means previous term, these are no big deal. Here, let's just run through a quick example. They want the first 5 terms of the sequence. Well, they start us out with a 3. So that'll be our first term. And then you go to the rule, and you say the rule says a sub n minus 1. So take the previous term. Well, our previous term is a 3, and then we're going to subtract 5 from it. So we'll do 3 minus 5 to get negative 2. Now you go back to the rule and you say, all right, take the previous term. Well, now our previous term is a negative 2. Follow the rule, subtract 5 from it, and you get a negative 7. And then you take the previous term, which is now a negative 7, subtract 5 from it to get a negative 12. That's giving us 4 terms, but that's the idea of recursive sequences. So we have touched on this before. Your arithmetic sequences can be written 2 ways. You can write the explicit rule, which is what you've done more of in the chapter so far. There's the a1 plus n minus 1 times d. You also can write a recursive rule for an arithmetic sequence. What you're going to have to remember is there's 2 parts to your recursive rules. You have to identify the first term. You have to give people a place to start. And once they know the first term, then tell them what to do with the first term. So you say, take the previous term, and then add that common difference. Geometric sequences, just like the arithmetic, 2 types. You can have an explicit form or a recursive form. So the explicit, what you guys have worked a lot with so far, that's the a1 times your ratio raised to the n minus 1 power. Recursive rule, 2 parts to this. Start out by telling everyone what the first term is, and then your rule, here is that previous term, and you can see that it's being multiplied by the ratio. So anyone following a recursive rule would start out with the first term you gave them, and then they'd say, well, what do I do with it? And they would say, okay, I take the previous term and multiply it by the ratio. This last slide just has us go through writing the recursive rule for a sequence. So first thing you have to identify is what type of sequence is it? Is it arithmetic, is it geometric, or is there some other pattern happening? So if you start with a 3 and then you go up to 8, 13, 18, we can see that we are increasing by adding 5 each time. So that makes this arithmetic, which means it has that common difference of 5. So the recursive rule, 2 parts. First is identify the first term. So everyone would know to start with a 3. A1 is 3. And then the rule is you tell them, take your previous term. So there's your an minus 1. And then what do they do to the previous term? They have to add 5 to it. And that will give us our recursive rule for that sequence. This next example, we can see how are they getting from one term to the next. Looks like we're multiplying by 4, which makes this geometric. So because you're multiplying by 4, that means your ratio is 4. So when you go to write the recursive rule, again, you have to start by identifying the first term. If you don't identify the first term, you can't even use the rule because you don't have a previous term to work off of. And then for a recursive rule, you have to tell people what to do to the previous term. So you could say, take the previous term, n minus 1, and multiply it by your ratio, which is 4. Now that times 4 because multiplication, I think on the rule on the slide before this, I did have it out front here, but out front or in the back doesn't really matter. Alright, this last sequence is a little bit different. You know, if you look, are you increasing by the same number? And you can see this is increasing by 1, then by 3, then by 12. So it's not arithmetic. Are you multiplying by the same number? And if you were to check the ratios on this, you know, you can take the second term 3, divide it by 2. So the ratio between these two is 3/2. The ratio between the next is 6 divided by 3, which is 2. So you're not getting a common ratio. So this, it's not arithmetic and it's not geometric. So now we just have to kind of try to figure out what the pattern is. So on these, you know, we could look at it for a while. Sometimes, and I don't know that we've seen too much of this yet, you may have a pattern where you have to use, you can do something with the first 2 terms versus the first term. So if you have a 2 times 3, can you see how if we take the 2 times the 3, we will get 6, which is our next term. Now let's take the next 2 terms, 6 times 3, and see how we're getting 18, which is the next term. And then take the 2 terms, 6 times 18, and we'll get the 108. So that's the pattern. If you multiply the 2 previous terms, you'll get the next one. So this one's going to look a little bit different when we set up our rule. You have to identify the first term. So A1 is 2. And because you have to take the first 2 terms together to get the third term, we're going to have to go ahead and identify the second term also. So we do need to give people the first 2 terms so that they can keep working. Now the rule, we know that we're going to multiply the 2 terms together. So what does the notation of that look like? So we can say, take the previous term, that's n minus 1. So far, you know, our rule is we have a 2, or our sequence, we have a 2, we have a 3. So if we're trying to get the next term, and we just said, take the previous term, well, your previous term is a 3. How do we tell everyone to multiply it by the term before that? So what happens is the previous term is just 1 term back. If you need to go 2 terms back, instead of n minus 1, that's going to be an n minus 2. And so now we're telling everyone, take the previous term, the one right before it, and then n minus 2 is 2 terms back, and we multiply those together. So that one's a little bit trickier, but we can handle it. A few videos on this section, make sure you watch those, take notes. This intro video, not enough to get you through the homework, so see what else is going on in those other videos.